In this video, I'm going to show you how we can use slope-intercept form to graph. Notice I only have one problem this time. That's because in order to do this, we have a couple different steps we have to do. So I want to make sure I have enough space for all of this. So if you notice the directions, it says write the equation in slope-intercept form and then graph the line. So remember what slope-intercept form is. Y equals mx plus b, where m is our slope and b is our y-intercept. So in order to graph the line, first we need it in slope-intercept form. So if you notice, my equation right now isn't in slope-intercept form. Actually, it's in standard form. Remember, ax plus by equal to c. So my first step is to write this in slope-intercept form. So if you recall how to do that, we basically need to solve for y and have our x term and our constant off to the other side. So let me rewrite the problem here. So to solve for y, I know I need to move my x term because it doesn't have a y anywhere near it. It's not a y term. So we're going to subtract this. We're going to use our inverse operations. Now I cannot actually combine these. These are not like terms. So this is going to stay as the expression 8 minus 3x. And then whatever was left over here is 2y. So I'm not done. At this point I need to divide by 2. So if I divide this by 2, I divide the whole thing by 2, this turns into 1. Now, I'm dividing both of these by 2. So, this is actually going to be 8 over 2 minus 3x over 2. Well, 8 over 2 simplifies, so that's nice. That actually simplifies to 4. But 3 over 2x doesn't, so we have to leave it as the fraction. So, I have it now in my almost in slope-intercept form. I have one more thing to do. If you noticed, my x term is to the right and my y term is over to the other side. So I need to actually rearrange these. So really, if I rearrange these, this is 4 minus 3 halves x. So that's negative. So if I rearrange these, it's going to be y equals negative 3 halves x plus 4. So here is my equation in slope-intercept form. And now that it's in slope-intercept form, I can use my previous skills of just slopes and intercepts and y-intercepts to graph it. So let's pull that out so then we know exactly what to use. So first off, our slope is going to be negative 3 halves. That means I'm going to rise a negative 3, which means I'm going down 3. And I'm going to run a positive 2, which means I go to the right. And our y-intercept is positive 4. If you recall, we did do this before, so this hopefully is just review. So now we're going to go ahead and draw our coordinate plane. And we need to do our labeling. And again, I'm going to use intervals of 1 on my x and y axis. So our y-intercept. Our y-intercept is 0, 4. Remember how to do this? We started our y-intercept. That's why we wrote it in slope-intercept form, because once I write it in this form, I can pick out my slope and my y-intercept very easily. So the y-intercept is 0, 4. So 1, 2, 3, 4 right here. Now, our slope tells us to go down 3 and to the right 2. So I'm going to go down 3, 1, 2, 3, and to the right 2, 1, 2. I'm going to go ahead and do it again one more time. I'm going to go down 3, 1, 2, 3, and to the right 2, 1, 2. I don't have to do it another time, but I'm just choosing to do that just to make sure I got the right pattern going for my line. So here are my 3 points. So basically it looks like the line will be about there. Now if you notice, originally if you looked at the line in this form, standard form, we can't really tell exactly that we would have a negative slope, would we? It's not until we actually go to solve it when we realize we have a negative slope and our line is actually going to fall. So this is how we use slope-intercept form to graph. We first need to put our equations in slope-intercept form. Once it's in that form, we can pull out our slope and our y-intercept, which is everything that we need to actually graph the line.